Hello, everybody. Welcome to this channel. I'm Payman Hassari. We know how to evaluate how well a model generalizes. The next step is to improve model's generalization performance by tuning the hyperparameters. Hyperparameters are those parameters that should be set before training starts. In this tutorial, I'm going to talk about how to find optimal values of hyperparameters. For this purpose, I use decision tree, which has different hyperparameters such as criterion, maximal depth, minimal leaf size, and so on. How to build a decision tree in RapidMiner is discussed in another video, and the link is in the description. Let's say we want to choose criterion to be Gini index, gain ratio, and information gain. Also, for maximal depth, we choose 5, 6, and 7. Because we have 3 different values for criterion and maximal depth, we have 9 combination of parameters and should build 9 models. And we choose a combination of parameter with highest performance. To do that, we use iris data that can be easily found on internet. Let's start. First, bring the data into the process panel simply by dragging and dropping the data, and take a look at the data. We have 150 examples with 5 regular attributes, and the class attribute here is our target variable. Next, I'm going to specify our target variable using a set rule operator. Bring the operator into the process panel, connect these two operators together, and configure this operator. The attribute name is class. The target role is label, which says that this is our target variable for this problem. Next, in order to find optimal value of hyperparameter, we use optimize parameters grid operator, which runs models for different values of hyperparameter and chooses the best model. Bring it into the process panel, connect it to the set rule operator, double click on it. It opens up a new sub-process panel. Now, what I'm going to do is to split the data into training set and the test set, build a decision tree on training set for each combination of hyperparameters, and calculate the performance. In order to split the data, I use a split data operator. Bring it to the process panel, connect it to the input, and configure it. In the partition, I'm going to add one entry, which is for the first training set, and I use 80% of the data for training and add another entry, and the rest, which is 20% for the test data. Okay. For sampling type, there are different methods to do so. I use automatic, and I use local random seed to be 1992 in order to reproduce the same data set. Next, I built a decision tree using decision tree operator. Bring it into the process panel, connect it to the split data operator. And here, decision tree, I don't configure anything. I leave it as it is. And now I'm going to make a copy of the decision tree using multiply operator. bring multiply operator here, connect it to the model. And next, I'm going to calculate the performance of the model decision tree on the training set. In order to do that, I use an operator called apply model. Bring it to the process panel. Apply model has two inputs. One is model and one is the data set. For the model, I bring it from the multiply, which is the decision tree model. And for the data, I use it from here, which is the training set data. And apply model has no parameters to configure. Next, I calculate the performance using performance operator. Bring it into the process panel. Connect these two together and configure this one. I choose main criterion to be first, and the main criterion is the main metric is accuracy. And now my model is complete. I connect this one to the output. So this is performance. I need the model as well. That's why I made a copy of the model here and I use it for output. And also I need to use the test data as well. I get the test data from the split data and connect it to the output. Get back to the process panel. Now let's configure optimize parameters. And if you click on edit parameters setting, and in operator, we choose decision tree. And for decision tree, there are different parameters that we can choose from. Let's choose criterion, as well as maximal depth. For criterion, there are a set of different values that we can choose. I'm going to choose Gini ratio, information gain, and Gini index. So accuracy and least square, I deselect them. And for maximal depths, also I can choose different values. The minimum, let's say 5, and the maximum, let's say 7, which gives me the values of 5, 6, and 7. Okay. And the rest, just leave it as it is. Now let's calculate the performance of the best model from this operator on the test data. In order to do that, I need to bring the apply model operator into the process panel and rename it first. Apply model for the test data. And in order to bring the model, I use this output from the optimized parameter grid. And for the data, I use this output as well. And next, I'm going to bring the performance for this model. Bring it into the process panel, connect these two together, rename it first. Performance for test data. And configure this one, which it should be exactly the same configuration as what we had for optimized parameter. And this is exactly the same as what we had. Connect it to the output. And I would like to take a look at the performance of the different model that we build with different values of hyperparameters. So in order to do that, I need to connect this one as output, as well as the best model that we have from the trainings. And now let's run the process. As you can see, this is the 9 model that we built with different values of criterion and maximal depths, along with their accuracy. For example, when the criterion is Gini index and the maximal depth is 5, the accuracy is 97.5%. And this is the best model that we have. the accuracy is 98.33%. On the training set, this is the confusion matrix, and the different values that we had. Criterion is gain ratio, and maximal depth is 6. And we have the performance of the model on the test data as well.